Assalamu alaikum. I hope you're doing great. Today I'm going to be showing you how to build a quadcopter or a drone like this using Steam NOOR kit from scratch. I'm going to be using this platform that I built using just basic material like wood I got from Home Depot. I 3D printed this arm. These are the arms we're going to be using for the Steam NOOR kits to make the quadcopter. And I got this digital scale or balance. So basically, once I get all the pieces here, I'm going to be testing the thrust of this motor. So today's class, or part one of the drone, is going to be talking. I'm going to be talking about especially the motor. Okay, how you select the motor for your drone. Let's go do it. So building a drone from scratch. So we're going to be talking in part one how to select motors for your drone. Very important. In this class, you learn how to select the right motors for your drone, understand the thrust to weight ratio, understand what is the kV rating, determine the correct motor size for your drone, and perform the initial motor and speed testing. List of material. You will need brushless motors, and you're going to need for quadcopter, you're going to need 4 of them. A couple of jumper wires. You're going to need 11.1 volts battery. You're going to need what do you call an ESP or electronic speed controller to control and drive the motors. You're going to need a servo tester to basically change the speed of the brushless motor, and a digital balance that we're going to be using for testing. And of course, 3D printed arms, as I showed you before, just like this one here. So, what is a brushless DC motor, or BLDC? So basically, a motor converts supplied electric energy into mechanical energy. That's what gives us that movement of the propeller. So there is various type of motors, but the one that we're going to be talking about today is the brushless DC motor. And why do we even call it brushless DC motor? So the inside, the rotating part, that is basically what we call a motor, and it has a permanent magnet. These parts where you have coil are called stators, and we have 3 of them. So reason why we call them brushless DC motor, the coils that around the stator, they are not located at the router, but they are located on the stator itself. So we don't need a brush between the router and the stator to pass the current to them. So they are in fixed position here. So how to select a motor? Well, very important, the selection of your motor when building a drone. Okay, the total weight is very important. Make sure basically that the entire drone be measured. Put a scale there and get that information. Including the fan, propellers, the 4 motors, the arms. We're going to be using Arduino Mega in this project. All the printed 3D material, anything you can, the battery that's gonna power the Arduino and the motors, everything should be scaled, okay, in balance. And those motors should be basically selected based on the weight of the entire drone. So basically, because we're gonna have to calculate and we're gonna test how much thrust we need in each motor to kind of overcome the weight of the entire drone. So that is the purpose. Very important we select the right motors to give us the right thrust to basically lift the drone and have a better controlling of the drone. So what we need to take in consideration is this frame size. So from the motor to motor, that's what we call a frame size. So let's say in our measurement here, I have 40 centimeter from the center of this motor to the center of that motor. Okay. So the weight of the drone, the size of the propeller will determine exact lifting thrust and the flying speed of your drone. So it's very important to know all these parameters. Thrust to weight ratio. It is very important to make sure that the motor selected for your drone can actually produce at least twice the thrust of the entire weight of your drone. So if we have 4 motors, and let's say we have 1 kilogram, the entire size, the weight of the drone is like 1 kilogram. So each motor should at least generate 500 grams, which is give you 2 kilograms. So you need at least twice the thrust generated by your motor to lift that 1 kilogram of your drone. So if the thrust of all motors is too high, the drone will have a better agility, but the problem, it will be very hard to control. Okay. So, and as I mentioned, the example I gave you, a 1 kilogram weight of a drone, we will need 2 kilograms of thrust. So that's almost 500 grams per motor. Okay. 500 times 4, that will give you 2 kilograms. So the thrust get generated by all motors should be at least twice the weight of the drone. And you will hear a lot about this kV rating. Here in this motor, we have 1000 kV rating. So what is this kV rating? By the way, kV is just a name. It's not a unit. So kV rating is nothing but the RPM, or revolution per minute. That is the amount of RPM generated per volt. So if you have, for example, a rating of 1000 kV here, just like we have here, okay, the total RPM generated by the motor, and if you're using, let's say, 11.1 volts battery, so we will have 1000 times 11.1, that will give us 11,100 RPM revolution. Okay, so that is the total RPM. So more voltage, the more RPM we're gonna get. More voltage, more RPM, and of course, more the higher the kV rating, the higher the RPM. So these values are, basically proportional. So, and of course, when you have your drone on air flying, wind can reduce the RPM as a resistance, as you know. Even you drive in your car and there is a high wind, it will reduce basically how fast the car is running. The same thing for the propeller. When you have a high resistance, high wind, your controlling or controllability of the drone is going to diminish. Also, the speed of your propeller can diminish because it will find resistance. So, what motor size should we use? So, generally, brushless motors are categorized by a number which has like 4 digits, just like this one here. So, we're going to be using 2208. So let's see what these numbers mean. So the first 2 numbers here, or the first 2 digits, This one designates basically the diameter of the stator. So you go measurements from here to here. So this is, by the way, the stator is here. From here, where you have the coils, all the way here, we have 22 millimeters. So that is the width of the diameter. And the other two digits, which is 0.8 in our case, that will give us basically the length of the stator, okay? How tall, okay? It's very important, you know, the bigger the diameter give us a surface, and the higher the stator, that will give us the volume, or more magnetic flux we can generate, and more strength and thrust we can generate. So these two numbers here, the 22 and 0.8, that's what determine basically our size of motor, okay? As I mentioned, this is the stator, and so the inside are the windings. So generally, the wider and taller the motor, more torque it can produce. So what kind of size should I use for my drone? So really that depends on the actual frame size of your drone. So for example, if I'm using this kit to make my drone, so I have to make sure that I measure distance from here all the way here. That is very important to that will determine the size of my drone. And this is just for test for now. It doesn't mean I'm going to be using 7-inch. This is a 7-inch propeller. I might reduce the arm, or I might extend these propeller longer to like maybe 10-inch. If we look at this table here, what we have frame size, we have propeller size, we have motor size, and the kV rating, okay? So if we, for example, if our frame size of drone is 40 centimeter, which is 400 millimeter from here to here, for example, then I will be using these parameters, okay? 450 millimeter, which is more than I have, which is good. More is better sometimes. You don't want to go overboard, maybe 10-15% more is good enough, okay? And these are my size that I can use for my propeller. So they are suggesting I should use either 8, 9, or 10-inch propeller. I ordered 10-inch propeller for my project. I'm still waiting it to be delivered. So I will be using the 10-inch propeller. And, you know, for now, I'm not going to be using the 2212 motor. I'm going to be using the 2208 motor and see if I want to actually increase it or maybe just decrease the arm a little bit, okay? So I'm going to be using 2208 for testing, okay? And the kV rating was suggested for this is 1000 kV, okay? And kV, remember the kV rating is nothing but the RPM per volt. How much revolution per minute get generated per 1 volt? And I showed you for 11.1 volt battery, we can get 11,100 RPM. So another parameter that you're going to be seeing is the N and P in the motor, okay? So basically, N and P are poles and magnets. And so for example, when you see in the motor a number such like 12N 14P, what does that mean, okay? So if we have, for example, this is the stator, we will have, for example, 12 poles, means 12 location where we have this coil, okay, where we have like magnetic field generated, okay, and the 14P P here, is basically 14 permanent magnets in this bell. Okay, so the rotating part, it will be this part, and this part is fixed. That is the stator. Now let's look at the movements of the motor. Okay, for a smoother flight characteristic, you need to use a pair of motor that are clockwise and counterclockwise, and for a reason that I will explain later on. So we will have, for example, in our quadcopter, like this one here. I'm still missing one motor here. I'm going to be using it for testing, and then I'm going to put it back. So, for example, we will have like an X representation in quadcopter. This one and this one, they're going to be the motors here and here. They're going to be rotating clockwise, and this one in an X, as I said, representation. This is called quadcopter X representation. Sometimes you might have drone made by only 3 motors, which is called tricopter. Okay, we're going to be building quadcopter. Okay, so in this representation of quadcopters, the direction of the motors you choose are very important. Also, when you buy them, make sure you get in CW or clockwise rotation, and 2 of them should be counterclockwise. So 2 clockwise and 2 counterclockwise. The propellers also make sure to get clockwise and counterclockwise. Okay, if you don't get those, you're gonna have problem controlling your drone on the air. As I mentioned, the clockwise movement of these two going to be rotating clockwise, and these motors, they're going to be rotating counterclockwise. Okay, and the reason you want to kind of neutralize what they call the yaw movement, because if on air, you want to at least make sure that your drone is stable and balanced. Okay, if you don't have this configuration, your drone might be moving to one direction or the other direction, and you cannot control it. So you want to have it in one stable location. Then you can actually exercise certain maneuvering that I will be talking to move your drone left, right, up, down. But this is very important. So how brushless motor work? So we're gonna see how actually the movement or rotation of that shaft, how does it happen? Okay. So this is the stator, and this motor we have 1, 2, 3, 4, 5, 6 ends. And then we have 4 P's. These are magnets, okay? We have one magnet here, another magnet. So 4 permanent magnets and 6 coils, okay? The 6 coils represents what we call stator, okay? And the rotor is those 4 permanent magnets, okay? So if we take one coil and see what actually happening, okay, let's just take one coil, and we're gonna apply electricity, current or voltage to the coil. So current is gonna be going through here, and then, as you know, when you have coil or even a wire that have electricity, there is some kind of electric magnetic field get generated. Okay. And the direction of the current, the force that get applied, and magnetic field, we can always use the right hand Fleming to determine that direction. But that's not the purpose of our class. So let's see what happened, how those movements basically of the motors are happening. So with the magnetic field, you will have north and south. So if we have here, for example, south, this gonna try to attract the north, and it's gonna rotation is gonna happen just like that, okay? And then it's gonna continue. If we trigger each coil at certain frequency, there is this rotation, because the magnetic field is gonna try to align itself with the permanent magnets, and that alignment cause rotation. So the electromagnetic field is gonna keep trying to align itself with the permanent magnets, and that would cause a rotation. But we can also produce more thrust in a motor if we kind of try to power these coils at certain order and frequency. There is a device called ESP, or electronic speed controller, that actually using it, and there's some IC circuit inside called MOSFET that actually power certain coils and block others, and that actually cause more thrust, and there's a faster speed of the motor. So using this ESP, we can have actually more thrust, and that's how a motor basically works, using the ESP and the electromagnetic effect of currents going through wire that produce some kind of a magnetic field, and that magnetic field will interact with the permanent field, and that will cause the motor to rotate. So generally, this is how it works.